What truly captivates me in the realm of science are natural patterns. These intricate designs emerge across various scales and profoundly influence our daily lives. Touching everything from advanced technologies like batteries to cardiac arrhythmia and cancer research. Patterns are remarkable because they represent self-organized phenomena, where individual elements come together to produce entirely new collective responses. Yet, as scientists, we found ourselves facing a significant challenge. Our understanding of the intricate mechanisms governing these complex processes remains limited, often hindered by traditional disciplinary boundaries. This challenge is at the forefront of modern science, the call for integration across disciplines. My research endeavors are dedicated to unraveling the mysteries of pattern formation in physiochemical systems operating far from equilibrium. With a keen focus on renewable energy and biological media, my work spans a multidisciplinary spectrum. From delving into fundamental theories like local and global bifurcation theory to real-world applications, such as the study of intracellular waves, the processes of branching, solitones, and rogue waves, and technological topics like renewable batteries and photoelectrochemical water splitting. I extend an invitation to the younger generation to join my group in this multidisciplinary endeavor to comprehend the intricate puzzle of nature.